I'm going to try and fix this Racal Dana 1992 frequency counter. I've had it sitting here for a few months now, waiting for me to get round to it, and I finally got a bit of time. I can go through and fix this thing, get this one out of the way, move on to the next thing after that. I've got power plugged into it, we'll power it up, and what is actually the fault is the buttons on the front panel here are definitely bad. Once some click, some actually do press in and come back out, some are stuck. That's stuck, that's stuck, stuck, that one works, works, works. So there's quite a few buttons here which just don't work. And basically this is a really common fault with these particular counters. All the Racal Dana ones, all this type, they all have buttons which fail. They gradually deteriorate over years and eventually they stop working. They get internally shorted and stuff like that. And they can cause it to crash, and when you try and boot up it won't boot up properly and all sorts of stuff like that. So we're going to pull this thing apart. Once I've done all the button replacement, I'll see if there's any other problems. It might not be the only thing that's wrong with it. It could be something else. Don't know. At the moment I can't get it to work properly, so I can't tell you whether or not the inputs work and that sort of stuff. So we'll do the buttons first and we'll do some testing on it and see if it actually works properly or not. If it doesn't, then we'll do some more repairs. So keep watching. So the first thing I've got to do is get this thing apart. And we've got a couple of screws in the back here. Yeah. Screw the washer there. So there's that. Now that slide off, yes it does. So there's also a little dent in the casing just here, you can just about see it. I'll try and get that out as well whilst I've got it apart. There we go. So yeah, there's that dent in there, which I'll give that a bit of a hammer. I should be able to get that out easy enough. So the complexity in these is actually quite high, I suppose. There's a lot of chips in there. And I've done some repairs on these things previously as well and other times, but this one's got the OCXO module on it. So that's nice. I don't have to do anything with that apart from maybe calibrate it. I've got a rubidium here which I can use to calibrate that. So once we're done, I'll probably need to tune that. We'll see how we go. If there's nothing else wrong with it. It's got a whole bunch of capacitors in here. Now, when I've done one of these before, I actually went through and recapped it. I think the main power supply caps were bad, and over here, which you can't quite see, but it's just under there. There's a cap in here which was bad before. When I did this before, most of the caps were actually okay, but I just did it as a matter of course because it's getting old, and why not do it? You know, you talk about $5 worth of parts to do mostly small caps. It's not much at all. We need to get this front panel apart, which is the screws on the side here. I'll take these nuts off the front of this so we can slide it off the actual posts, and then that will give us access to the front panel. And we've got to mess around this a little bit to get the front panel apart, but it's not that big a deal. Now to get these nuts off, you usually have a tool like this, little spinner thing. It's got some little posts that stick out the end like that, and you should be able to slide it over and it goes into little slots on the nuts and you can turn it. But unfortunately I don't have one the right size for this particular job. This is too small. I do have like a T one which I made up years ago for doing radio work, fixed on the mic sockets beautifully, but it won't go over these. It's about the same physical dimension, but it won't actually go over these posts because it doesn't have enough depth on it. So I'm going to have to try and use a pair of pliers and see if this will work. Now, I don't think this quite go into the slot, so I'm just going to grab it hard and see if I can get it to turn. There we go. Let's go. That's that one. That's going easy now. Binding a little bit, but that's okay. That's the yellow one. Just try and be careful not to scrape the front panel as I do it, or to slip off. So I'm grabbing right where the T-slots are to try and hopefully get the bind in there. There we go. So not the easiest way of doing it. I really need another one of these. If someone knows where you can get one of these which fits over BNC sockets, please let me know, because I definitely do want one. I've forgotten what they're called now. Someone did tell me what they were. They were was it Mike's Radio Repair told me what these were called, which I've now forgotten. So I don't know what they're called now. I've forgotten. So you know that makes it a bit hard to find them too. They have a special name. Let's get the screws out. Now I've taken the nuts off the front. The middle one stays in place because we've got a little SMB connected to take off. These are PZ1 screws. Make sure you use the right bit for these, otherwise they'll tend to slip out. Now inside here we've got a few things I have to watch out for. They will just slide out, but it's got a header connection in here which links the front panel to the main board. See that header there? So that just slides on, that's what does the interconnect. But I've also got in here a coax cable there which you have to unplug, so you can't just yank it the front panel off. You have to disconnect that as well. That's the middle channel C input. So sometimes you have to actually lever it a little bit in the front. There we go, that's coming out. That's that bit. Now we've got to disconnect the SMB. Let's get a better shot of this so you can see what I'm doing. Alright, so there's the two headers there. And here's the SMB cable which you have to unplug. Just here. There we go, that's off. So that's that bit. Now we've got the front panel off. That was the easy bit. Alright, so you've got to take these screws out of here to get the front panel PCB out. And then we can see what we're dealing with. But there's lots of joints here we have to desolder. It takes a while. One of the hard bits actually, there's a bunch of switches down behind this IC here. And we have to take the IC out in order to access the pins of those switches to allow us to desolder them. Okay, a little bit there, get that screw. Okay, so there's a front panel assembly which you can take off. And there's the other side. Now you can see that some of these LEDs have got these little sleeves over them, so you don't get ghosting across the individual digits, like on the indicators over here. Otherwise that indicator will be on, it will light up this one as well next to it. So that's why they put this sleeving over the LEDs. And these ones here don't have that. So it's not every LED that has that. And actually, when I've done this previously, I put some sleeving over these other LEDs as well. I could put one over this one and these ones here, because I did notice that there was some happening to these other indicators over here as well. It just seemed like a nice way of tidying up. Just a little bit of effort, a bit of sleeving over these ones, done, not a big deal. So we have to take off all these button caps and make sure we don't forget which ones they go onto. And I'll actually show the switches I'm going to use actually. I've got a bag full here. I did find a source for these switches. These aren't exactly right, but they're really close. Now these are, I've actually got two lots. So I've got these white cap ones are my original ones, which I picked up probably a couple of years ago. I bought a bunch of them at the time, and this is what I've got left. And I've also got some other ones which are black cap, which I've sourced recently. I'll probably chuck a link down below for those to encourage people to buy them, because if you're repairing one of these, you're going to need these switches. And like I said, they're not exactly right, but it's the closest switch I've found so far. If you know of a switch which fits better than these, let me know. But basically, these caps, you see the post on these is very different. It's a long post and a short switch body. This is the opposite, a long switch body and a short switch. And it will go on like that. But they don't actually lock on, see they're loose. So what I have to do when I did these ones before is I put a little bit of adhesive in there. Not permanent adhesive, just a temporary adhesive. It holds it well enough. Then it just glue the caps back on again, and you can pull them back off still. You still can get them off, but they won't just fall off. I've used that on other gear. I've done a few of these things now, and they've all worked the same way, and they've all been absolutely fine. But these switches work pretty well to replace these ones that are in here now. But I'd like to obviously get this original type if I could, but I haven't found them. If you can find them, then great. But I haven't found them. Alright, so I'll sort of switch caps off. I've organised the ones which I took off from the number keypad in the sequence they're in. So if I do forget, they should be laid out correctly anyway. And obviously the blue button's just on the reset continue button over here. So I now need to desolder all of these switches, and that's what's going to take a while. There is also a single electrolytic capacitor on this board, so I'm tempted to replace that as well whilst this board is out. You know, it's one cap on that board, it's not a big deal to change it, it's nice and small. Even if it tests okay, I think I should still just change it and have done with it. And as you can see, you've got this row of switches just here. You can see they've got the two rows each side from the IC on the back of the board, so this has to come off. What I've had to do in the past is actually cut the, left the socket in place, taken the IC out obviously, and I've cut down the actual socket in the centre part. I've cut that middle bit out, so then I can get in there and desolder the pins, rather than desoldering the whole socket and risking further damage. You know, it could actually damage the double-sided board and stuff like that by doing that. Sockets aren't easy to get out. Bit fiddly sometimes. Sometimes they come out easy, but often no. So it's easier to just cut the socket in and out, and then I can just drop the IC back in again afterwards. It doesn't matter. It doesn't actually care about the inner part of the socket being there. So anyway, we'll get these desoldered. Right, so it's a bit counterintuitive, but instead of desoldering, I'm soldering first. There's a reason for this, because it makes it easier to desolder it. So you think, oh, what are you taking, putting extra solder on for? It just freshens it up, gives you some fresh flux, and it just makes it all nice and easy to desolder. It makes a big difference to getting it desoldered if we just do a little bit first with some fresh stuff, and it does make it a lot easier. It takes more time obviously, but the end result is better. So initially I'm just going to go around and do this with it and just put extra solder on each one. Now I think these pins on these switches, I think one pin is a different size to the other. I'm not sure. Let's see how it goes, because it looked like my desoldering iron tip would only go over one of the pairs, one pin of each pair. That's what it seemed like, but anyway, you get the idea. You don't see me solder every single pin, do you? Well, let's start desoldering some of the switches, and I'll get to this one when I get to it. So let's see how we go. This is going to be a little bit noisy, I'm afraid. It's not going over that switch leg. I think my suspicion about one leg being bigger than the other is correct. That's a pain. I must change bits halfway through. Never mind. Oh, I think I remember now, this little cover here for this IC package, that just clips in the middle piece there. So it does actually allow me to cut down the sides of this. So I think I'm going to do that, I'll give that a go. Hopefully without cutting through traces. Last time I used side cutters and I just nibbled them way down. And we'll see how we go with that. So what I've done is I've just scored down the edge of this with my knife, hopefully without cutting traces, and then I'm actually just trying to tear it off. There we go, that's working. That's working a bit easier than I did last time I did it actually. It worked quite nicely. Last time I used side cutters and just nibbled down the sides, but this way is working a little bit better. It's always nice to find a better technique. Alright, so that's all that broken out, so now I can get to those joints in the middle and desolder those ones. Alright, so I've changed a bit. Let's desolder the rest. Hopefully the switches will start falling out. I'm going to give it a lean at the same time as I desolder it, and hopefully it will pop out. That's one. Wish it'll come out that easy, we'll see. So far so good, they're all coming out. The last one I kind of wiggled it back in again as I was taking it out. Let's heat up a bit, here we go, that's out. So they're all dropping out nicely. Cool. Okay, here we go, there's a pile of switches removed. And one bare board. Now we need to start looking at putting new ones back in. This is where it gets a little bit tricky because alignments on these aren't perfect, which is where it takes a little bit of fiddling around. Alright, so they do have a little bit of slop in them, they can move a little bit up and down. You have to make sure they're bedded down and soldered in nicely like that. So it's not a big deal, but it just takes a little bit of care to try and make sure they're all lined up, because they do have a bit of rock in them. So as long as they're pushed down hard when they get soldered, then they should be fine. But that is almost as tedious as taking all these switches out. So what I'm doing right now is just tacking the switches in place. Just doing one pin, and then I'll come back afterwards once it's actually all in place, and I'll bed them all down properly, make sure they're all nice and flat and square, and then I'll solder the other pin whilst also holding it, of course, to make sure it stays flat and square, and then we should be good. It's a bit of a messing around thing, you know. You've got to get them exactly right. Otherwise you have issues with the switch caps rubbing on the front panel. Right, so that sort of switch is replaced, as you can see. You have to sort of kind of look down them to make sure they line up and that kind of stuff, to make sure there's nothing that's a bit wonky. They pretty much line up. They're all looking pretty good. obviously I'll clean the flux off here, I haven't done that yet, and I've also replaced this capacitor over here with a new one, just a matter of course, just to be sure. Okay, that's the board cleaned up. Let's really go back in again, apart from putting the IC back in again. I need to make sure I get this back in the right way. I think it was that way up, but I need to double check. Alright, so what we've got to do next is fit the button caps back on again with the panel back on this. So this is where it can get a bit fussy, because you do sometimes have to do a bit of deburring around these edges so they don't rub. That's been my experience on previous ones anyway. Alright, you do have a bit of play in the actual mountings, not much, but there's a little bit in there. So it gives a bit of give there. But if you look at these switch caps, see, they do stick through, and they are kind of centered. You know, you basically have to make sure they're centered in these holes, and then it'll be alright, pretty much. Alright, so you have to just make sure that the caps don't rub on the sides, and that's what I found before, is I need to do a bit of deburring on the metal casing behind the panel here. And like on these edges, just trim a bit of this off, because sometimes they're not very well formed. They're punched obviously, but they sometimes I just need a bit of a trim off them so they don't catch on the buttons and make them stick. So that's something that needs doing sometimes. So I'll see how it goes anyway. I'll put these screws in this, line this up, and go from there. Alright, so I fine-tuned the alignment of some of these. I just got the buttons, put it on here like that, for example. And if it is slightly off, I was, just sort of force it onto the actual shaft, and then I'll just resolder those pads on the back there and just get it to settle in the right place. So I've gone through and just checked every single one, and they're all now not binding up. I say as I find one which isn't quite fitting right, like this one here. That one is binding up. Let's just do this one. If there are problems with binding after I've done that, then I'll go through and just trim the inside of the buttonholes, because some of, as I said, I've had to do them before on other units. I think it's if the front trim isn't quite aligned with the holes properly, it'll tend to skew it a little bit, makes the holes effectively smaller. But that seems alright. Because the holes are, well, these buttons are very slightly tapered. It's very slight tapering, it's like normal for injection molded stuff to have a very slight, what's called draft on them. And originally this button's obviously sat further back, so there's a bit more clearance. So now there's a bit less clearance. It takes a bit more fine tuning. Anyway, that's all right. So I'm going to do is use some of this stuff, my liquid electrical tape, because it's not permanent. It can be picked off again later on, and it adheres quite well to these kinds of things. And you can just glue the buttons back on with that, and that holds fine. I mean, I've done this many times on other units. It's a little bit tedious, but it's not that bad. Squeeze a little bit of that in there, like that, just inside there. When I set it onto that, it will bed on nicely, and we'll just repeat that. Now the other thing, sometimes these have got these little burrs on the side, the gates. It's called a gate right there, where the plastic is pushed into the mould when I make it. Sometimes I have to trim those off as well, and actually I think I might go around and do that, because that's something which is usually a good idea. Just trim that little bit of flash off there, just it helps stop them catching. So I'll do that now as well. Let's get my scalpel. I was going to show you what I'm going to do. Just on there like that, and just go trim, trim, trim. Get that smooth. That's gone. And I'm going to do that for every button. Alright, get in there. Just doing the number keyboard now. Just as easy as that. Make sure it fits, and then if it's binding a little bit, then adjust it, but it's looking okay. That one's binding slightly, that one. Screw a bit of trim just down here. Like that. It's catching on the edge just a little bit. What it is, they've got a part line. It's called a part line. I'll explain it. So on the edge of the fittings, well, parts, there's a very slight ridge right on the edge there. Probably can't really see it on this one. There's a very slight ridge. And that's the part line where the mould faces are when I make the product, or part. And there's a very slight ridge there, and that makes them bind a little bit too, so trimming that little ridge off helps us too. Right, last one to go on. Does it fit? Feels right. Oh, it's binding a little bit on the trunk, pull it back off, so maybe we'll just trim it slightly. That one thing's binding up. Let's try again. Yeah, it feels better. Okay. And done. That's it. That's the buttons on. Now I have to let it dry for a little while before I try and put it back on again in case I knock them off. Just pushing them down again, make sure they're all bedded down properly. Obviously the trade-off with this is that the buttons stick out further than they did originally, but you've got new buttons. This is going to be good for another 20 years. So let's go through and look at these buttons which I've pulled out, and these ones seem to at least function okay. They press in and pop back out nicely as they should. These ones here are all bad. These ones are definitely failed. So we've got 8 definitely dead buttons and a whole bunch which probably still work. But who knows when I could fail as soon as you put it back in. So I'm going to put these to one side. I did the same thing before when I repaired another one of these, because I kept all the buttons which looked okay. I put these to one side as like emergency buttons. Maybe one day I won't be able to source these buttons anymore, and then I might have to resort to using originals which are salvaged. So I'm just keeping these to one side, and maybe one day they'll get used, maybe they won't, who knows. But just about ready now, put this one panel back on again. So let's look inside one of these failed switches, and this one doesn't actually push in. So if you look at this one, which is a good switch, you see it pops in. This one does not. So let's pop this thing open and have a look at it and see what's going on inside. Well, I think I've got it to move. Looks like it. Let's have a look. Alright. Contacts, that's all that's in that bit. Nothing in the wrong place. And here is the actual bit which makes the contact. And it should be springy. And it isn't. So basically it's got this assembly here which should be like a rubber bush. But it's rock hard. So try and get it out. So it's a rubber bushing like this. So this is, it's gone hard. It should be flexing and pushing in. Well, if I push it down, that should clamps in if it's working properly. It doesn't. It's just rock hard, not bending at all. So this is what goes with these things. They go hard inside, and then when I do get pulsed like that, then they break. Yep, that's what goes wrong with them. So now we put it back together again, and we'll find out if it's got any other faults. So first thing I have to do is put this SMB connector back on. Then we can line the front panel up. Now I've got to line up these headers in here, otherwise we'd have a problem, but those need to line up and then it will be okay. Come on, there you go. Wiggle it around. Yep, they're going down. That's all good. That's all pushed out. Put these side screws back in again and we can try powering up and see what happens. Right. Front panel mounted again. Obviously I haven't put those nuts back on there yet. Let's power it up first, see if there's any problems we need to deal with in case I take the front panel back off again. Right. Turn this on. At least it's doing that. Let's push these buttons here. Yep, that's working. It's looking promising. Modes, which I can't quite see. A bit dark. But yep, that's working. First we'll test these inputs and see what we get. But so far it's looking like it's fine. Alright, so I just powered up my rubidium standard here, which isn't actually used that much. I only use it when doing calibration stuff, so I don't actually have it running the whole time. So I'll just power this up, and as you can see, it's at least reading the frequency, and you'll see it is drifting up and down as the rubidium's warming up and stabilising. That's completely normal. As it sort of tries to find its tuning point until it's heated up, then it will lock on. So it's at least counting, that's good. And if I plug it into the B input, you'll see the trigger light is flickering. You probably can, anyway. There you go. So it's sensing the trigger for that one. And put it on the C input. There you go. So the C input is also working, so that's good. I'll just leave this to run for a little while, let it settle down, and we'll check the accuracy. So the frequency is currently drifting up. The rubidium standard's locked. You can see the green light on there, that's now locked on frequency. There will still be a little bit of stability going on, but it's close. And the ovenized oscillator on this one is getting warm. I can just feel the warmth on here, so that's definitely heating up. And you can see it's pretty much consistent now, it's just drifting upwards. So once this reaches proper frequency stability, then this should be about right with a bit of luck. But it's looking promising. This is still on input C right now, so I'll let it stabilise on input C, then I'll go back to A again, check it again. So interesting, now you can see it's 0 to 11. That's because it's overranged. There you go. There's 10 megahertz there. So it's still not quite there yet. Still not stabilised properly. But it does seem to be slowing down. It's actually drifting back down again now. So it's looking like it's peaked. And now it's just going to find that point where it's temperature stabilised. Yeah, definitely a bit of warmth there. So that's good. See how close it ends up being. Don't forget, I'm using the wrong input for this right now. It's a 10 megahertz signal, and this is rated at 40 to 1300 megahertz on the input, but it's still obviously reading it okay. But I want to see what it stabilises to, then I'll swap it over to the other one. Alright, so it's settled down quite well now. It's now sitting at 16, so that's kilohertz, hertz. Get it right? Kilohertz. That's hertz there. So it's 160 millihertz, I suppose, at 10 megahertz on that input. So that's not too bad, really, is it? And that's kind of alright. Obviously, the rounding showing up over here. That's right. So you can see I've got my other unit here out. This one normally sits in my other lab. This is one I fixed previously as well. Same issue, had the buttons bad, so I've replaced the buttons on this one already. This looks like it's an older unit, not quite in such good condition. This one's a bit tattier than the one I just picked up. So what I'm thinking I actually might do is keep this one, sell this one, because obviously I want to keep the better one for myself. So I'll just turn this on a couple of minutes ago. I just want to see how this stabilises relative to how this one stabilises with the OCXO, because they both got OCXOs in them. This took about half an hour to stabilise, so I'm going to see how this one goes. What I'll do next actually is I'll chuck this onto the standard input A here, use that input instead, and we'll see how that changes anything, if it changes anything at all. So increase the resolution a bit, so it's got the same kind of error there. So here as you can see, I've just plugged into this one instead, and it's quite a way off and drifting in the right direction, so this will take a while to warm up as well. I just want to see if this one warms up any differently to this one. Because if one is faster to settle, then I might swap the OCXOs over, because one might be better condition than the other one. But this is like a newer unit, so I think I might go with this one anyway. So one of the things I don't actually like about these particular counters is that when you've taken the input off, it will leave it on display. So you may lose the signal, and you glance at the display thing, oh, it's all still good. But actually, there's nothing there. Obviously, you've got the trigger inputs here, which will flash when it's got a signal going, like this one's doing. See it flickering away, which tells you it is getting a signal. But if you're just glancing at the display, you don't necessarily notice that. And it's caught me out a couple of times when I've been doing something on a piece of gear, and I've not actually noticed that the signal's disappeared, and it's not triggering properly, and it's got a reading on display. So I will actually, I don't know if there's a way of actually setting this up to do that. I mean, I've never read the manual for these things. So as I've never read the manuals for these things, if I've even got a manual, I don't actually know if there's a way of telling it to not do it this way. I don't know. Maybe there's a setting for it. I don't know. There could be. If you know, let me know, because I don't know. Alright, so I've left this warm up for a while. This is still warming up, this one. Let's see what we get. There's resolution is what I'm trying to push. 53, so it's kind of stabilised. I've also got the casing back on it now, and that's kind of where it's sitting now. Is about, what's that? Hertz, there, hertz. So it's about 500 millihertz, something like that. Yeah, I mean that's not too bad, is it? But I can tweak the OCXO if I need to get this right. But it's still got a little bit of drift there. It's not perfect yet. I have to sort of wonder how long it's going to take to warm up properly. So it seems to have stabilised now to around 14 millihertz on here. So this one's looking pretty good. This is my original one. So that I calibrated a couple of years ago now. Maybe 3 years ago. Not sure exactly, but when I did repair on this one I calibrated this one against rubidium. So it's a very slight difference there, but not much. So let's try it back on this one again. This one's it's basically stabilised. And it seems to stabilise quicker than this one did. And this one's something about sort of 17, 18, which is kind of stabilised as well. I think it was like 17 last time I looked at it. So not too bad. This needs a slight tweak to get it down there. But well, let's give it a twiddle. I've just taken the plug out of the fine adjustment. Let's see if we can get down there. Got a screwdriver in the back. See if I can get this to actually lock into the adjustment and actually work. I'm using a ceramic screwdriver. You can't see what you're doing, and the adjustment doesn't actually line up the hole properly. Okay, I've got a different screwdriver in the slot. Let's try this one. Might need to use the course adjustment. We'll see if we can get there with this fine adjustment. It's getting pretty close though. Must be almost out of adjustment. Must be. I'm just doing a little bit of time now. Okay, I think that'll probably do. Oh, there we go, rounding. Now when I want to put the plug in the back, it will change the temperature slightly, so it might affect it. It's also currently 27 degrees in this room, so it's pretty warm. It's actually creeping back up again. Now I put the plug back in, so I may need to look at that again. Might be a period of adjustment and settling, adjustment and settling. So this is the one I want to keep, and I'll sell this one. I'll readjust this one as well before I sell it to get as close as I can. I'm not sure about the OCXO on this one. I'm not 100% convinced the OCXO on this is okay. It just seems a little bit drifty. Don't know. I'm not sure I trust this one. It could even be power supplies. I mean, this one's been recapped. When I got this one, I completely resurfaced it, put new caps in, that sort of stuff. This one hasn't been done. I only done that front panel capacitor. The rest of it isn't done. It might need doing. It could be there's some ripple on the power supplies which is causing problems. It's possible. I wouldn't rule that out. So now it's drifted back up to sort of 13, 14 again. Yeah. Stability of this unit's much better. So I think I might recap this. I've also got the thing on the bench. It's not much to get apart to do the recapping. And I've got most of the parts here I need. Maybe not all of them, but certainly most of them. Yeah, I mean this one definitely is much more stable. I mean you saw how much this one was drifting around before. There's still a little bit of drift on this one, but nowhere near the same extent. Alright, so giving both a bit of a tweak. I'm just letting this one stabilise again. So that was sitting at 4, this was sitting at 4 before. So this one's still stabilising again after adjusting it. You'll see how these go. I just want to see how these track together. I've put a T-piece on and put them in parallel with each other. So if there's any drift, it will mean it will be a rubidium. If they both drift by the same amount at the same time. So we'll see. I mean, I don't know. Maybe I'm just not giving this enough time to stabilise because it's looking pretty solid now. I say as it drops down by 1. But yeah, I just want to get them both tweaked and get them nice and close. And I'll sell this one, I think, and keep this one. and maybe recap it. Although it seems okay now. I mean, it's better a little bit of drift, you know, just nothing's perfect, but maybe it's alright. I don't know, maybe caps are okay. Yeah. I'm just feeling a bit lazy, I can't be bothered doing it, to be honest. Well, it's been a few minutes now and it's still the same, so I think I'm happy with this. This looks like it's fixed, it's behaving, inputs definitely work, that sort of stuff. I think it's good. Obviously I don't know about these extra controls on the panel, no idea, I don't tend to use them anyway. I just tend to plug in something and see what it spits out on the front panel. So I know there's all sorts of extra features you can do on here and filtering and things like that. Which I have used filtering from time to time, but not often. But it's looking pretty good. I mean, actually this is dripping one just then, and so is this. So maybe that's a rubidium drifting very slightly. I have to wonder. Or it could just be synchronising the drift. I don't know. Anyway, I think it's fixed. So if you found it interesting, give us a thumbs up, like the video, subscribe if you're not already subscribed, and I'll catch you in the next one. Bye.